Today in class, we learned about quadratic functions. We've spent much of the time this year learning about linear equations, linear functions, and the main characteristic of something that is linear is that when it is graphed, it has a straight line. Quadratic functions are very different. They are part of the nonlinear group, which means they are not straight. And what we know about quadratic functions is that the graph of a quadratic function is called a parabola. And a parabola is a U shape. And we've been learning the last couple of days that the U shape can either be opening upward or opening downward, and the vertex can be at many different places. But today, what we want to do is take our knowledge a step further. We want to talk about how do we graph a quadratic function. So if you look at example 1 on page 336, we are going to try and graph a quadratic function. So I've already got the parabola graphed on the board for you, but how did we get to that point? Well, the nice thing is we're going to graph quadratic functions in the exact same way that we graphed many other functions. So linear functions, what we did is we used the function, we created a table. From the table, we found ordered pairs, and from the ordered pairs, we were able to plot the points. All right? So let's see if we can come up with a timeline that, or a step-by-step method for solving this. So number 1, we have to make a table. Okay? The second thing we're going to do is we're going to come up with our own x values. So we're going to create x values. The third thing we're going to do is we're going to substitute the x values into the equation. All right. Then the fourth thing we're going to do is we're going to solve that equation. And 5, we are going to determine the y values. Okay. Then after that, so let's start 6 over here. This number 6 thing we're going to do is determine the coordinate pair. So we're going to determine the coordinate pair or pairs. Okay. Then number 7, plot points. And then number 8, draw a line. So let's review that again. We're going to make a table because we need to have coordinate pairs in order to make a graph. We need this. We need coordinate pairs so that we can put them on a coordinate grid and draw a line. So in order to do that, we're going to make a table. We have got to create our own x values. We decide what those are going to be. And that's the hardest thing for a lot of the students. Then we're going to substitute those x values into the equation, solve the equation, determine what the y value would be, then determine the coordinate pair, plot that point or the pair, and then draw a line. So let's start off with making a table. So here we have our table kind of already established for us. So number 1, we're good. Number 2 said to create x values. Now, when working with quadratic functions, we need to consider using some x values. As you can kind of look ahead to what we're going to get, you can see that we have half of our parabola or U shape is over here in quadrant 2, which means the x values are going to be negative. So we need to choose some negative x values. So I'm going to choose -2. I'm going to choose -1, 0, 1, and 2. So we usually want to choose 0 and 1 and small numbers that are easy to calculate that will give us some results. So we've created the x values we're going to work with. Now we substitute. So notice we have this function, which is x squared, y equals x squared. So I'm literally going to take the x value that I chose or created and substitute it in for x. So now instead of x squared, I'm going to have negative 2 squared. And negative 2 squared is simply negative 2 times negative 2, and I know that is going to equal 4. So I put negative 2 into the equation, I get out 4. These tables can also be known as an in-out table or a function table. So many of you have learned that in 7th grade. So I put in negative 2 to my function, and I got out 4. So that means 4 is my y value. So now my coordinate pair is the x value and the y value together. So its coordinate pair is going to be negative 2, 4. Okay? And so what have I done so far? I've made a table. I've created x values. Okay, so table, created x value. I substituted that x value in to my equation. I solved my equation. I determined what my y value was. That allowed me to determine my coordinate pair. So now I need to plot the point. So if I take this negative 2, 4 over to my graph, I'm going to go negative 2 on the x-axis and then 4 up, and I plot my first point right there. All right, so now I need to plot the rest of the points before I can draw a line. So let me step you through this one more time. So we've got negative 1. I'm going to substitute that in for x, okay, and I end up with negative 1 squared, and that's going to equal 1. So my y value is 1. So when x is negative 1, y equals 1. I've determined my coordinate pair. I'm going to plot that point, negative 1. 1 is right here. Now I'm going to continue to do that for the rest of these. 0 squared is 0. So my y value is 0. So I have the point 0, 0, which will be there. I have 1, which is substituted into the equation to get 1 squared, which is 1 times 1, which equals 1. So when I put 1 in, I get 1 out. So now I have the coordinate pair 1, 1, which is over to the right 1 on the x-axis and up 1. And then one more, if I put 2 into the equation, I get, instead of x squared, I get 2 squared. 2 squared is equal to 4. So my y value is 4. So my coordinate pair is 2, 4. And when I graph that, that's going to be right here. And then all I have to do is make a nice U shape out of these points that I have. So I try to connect the points as best I can. And when we're doing curved lines like this, it's not going to be nice and straight and perfect, but you get the general idea. So we were able to graph the quadratic function. We came up with a nice parabola, and we were able to take care of all those steps. So we made a table. We created our x values. We substituted those x values into the function. We solved the functions. We determined our y values, which helped us to come up with the coordinate pairs. Once we had our 5 coordinate pairs, we were able to plot them in the graph. And once they're in the graph, they helped us to do our ultimate goal, which was to draw a line. So hopefully that helps you to break this process down and be able to graph a quadratic function. There is one more example here before we get started on our own. It's a little bit more complex, but notice they went through the same steps. They're going to create a table. What did they do before they created the table? They came up with x values. Okay? After they had their x values, they substituted them in. Notice they took the negative 2 for the x value, substituted it in. And then what did they do? Well, they solved it. They did negative 2 squared, which is 4, and then a negative 4 plus 4 is 0. So they solved it and got 0. All right? They realized that that was their y value. Then they took the x value and the y value together and came up with their coordinate pair. Once they had their coordinate pair, they plotted it over here. So I have the point negative 2, 0 right here. And then they did the same process with all the other x values. And as you can see, after they plotted all these points, they were able then to come back and graph their parabola. And notice that this one is opening downward primarily because the coefficient of the x value was negative. So that is how you graph a quadratic function. I would like you guys to try this on your own. The got it problem at the bottom of the page. I put a table up on the screen for you to help you. Those are the x values that I recommend that you create, -1, 0, and 1. And hopefully you should end up with a parabola that looks something like that. Okay, go ahead and get started.